Our next section, our general topic that we would like to talk to, is component design and development. And so let us first hear from the client as to what he thought component design and development consisted of, and then we'll go to the senior manager from Westinghouse and follow the same pattern.
Well, extensive design, development, and testing of the major components as a part of the AAC FFTF program was a very significant part of all this. Since the program was going to require sodium-cooled components, other major components for the fast breeder program, they set up an extensive development program with various manufacturers across the country to develop and test components for FFTF, with the thought that those developments and design developments would carry on through then into the program. That was the strength of the project came in part out of that program of testing.
And now we could hear from the senior Westinghouse manager who had to take these components and assemble them into a reactor plant and make sure they were tested so that they performed as they should in the reactor plant. Bruce?
Thank you. When I arrived at Richland, my first job was to take the package of testing that was being conducted here for the FFTF. I quickly realized this is a new animal. It's a sodium-cooled power with mixed oxide fuel, like nothing in the nuclear Navy program, or at least not very much. I came to realize, because of the later on involvement in the plant, that there were great payoffs from this blizzard of testing that was performed by the designers. Thank goodness that they shook out all that they could from those design concepts. They validated the individual pieces of equipment and systems. We built facilities here at Hanford to do more testing. We even had a sodium fire test to determine whether you needed to line the concrete in the various cells of the plant. They were extensive. And one of the carryover messages I would accent is that this testing is essential. We did it well, but we still had seismic 3/1 problems. We had to replace all the snubbers in the plant. We had insulation difficulties. There were construction difficulties despite all of this testing. So you couldn't ensure that it was full, over and done. You had to still be wary of it. But thank goodness that we did that much, and at a high cost. It cost a lot of money to do that testing in the vendors' plants. So when it comes to the component design and development, a strong recommendation is to be sure that you plan to do extensive testing to avoid big setbacks during the construction and startup.
Well, just to kind of piggyback on that, this, again, was, as indicated earlier, it was a national focus. The government was fully behind this. And as a consequence, a lot of this component testing that Bruce referred to was not done at Hanford. A lot of it was. But in the physics area, for instance, this is, again, a fairly new design. And therefore, we didn't have the kind of models that we have today. As a consequence, there were a lot of testing done at Argonne National Laboratory over in Idaho. With the critical facilities, because we needed calibration. We wanted to know when this reactor, when they pull the rods, it would go critical. And so there was a lot of that done. A lot of testing done in California and other places. But as Bruce indicated, a lot of it was done here too. Complete mock-ups of the in-vessel fuel handling machine. I mean, this is, once the sodium is in there, you can't see. It's opaque. You can't see through it. Therefore, we had to know that, in fact, as these arms moved around and so forth, that they would really work. And I personally was not involved in that, but I remember being overwhelmed as I visited some of these facilities and noticed that there were full mock-ups, the pumps and so forth. And I think this is absolutely crucial. We were fortunate that we did have the national focus. So everybody that was good in this business, we kind of had a role. So we weren't fighting over crumbs and that sort of thing. It was well funded, and we did it. But as Bruce indicated, having actual component testing of at least those critical portions of the plant completely debugged, if you will, before we put it all together was absolutely essential and made this run like a Swiss clock.
One thing, too, to point out is that you're not out there buying equipment off the shelf.
Yeah.
Most of this equipment, especially the major pieces of equipment, were engineered equipment. There was nothing like it in the world. So not only were you involved in component development and testing, but you were actually involved in developing vendors and suppliers, because there was no one out there that actually built this equipment before we got into the design and construction of this stuff. So that was a large part of it too, was actually gaining the attention and getting competent, good people and companies out there that would agree to work with us in designing and building the equipment. And then, as was pointed out earlier, a lot of the components went through extensive testing at the vendors' facilities, at other test facilities, before it ever came in here and got installed. And then we went through construction tests to make sure it was installed right. We did many walk downs of the equipment, walking each piece of pipe hand over hand to make sure that it went from point A to point B like it was supposed to, and connected with the right kinds of equipment. Made sure that equipment was installed right, and then came back and did acceptance testing of the whole system to make sure that once we got everything up and running, the system worked as it was supposed to and met the design criteria that we established. So lots of thought, lots of forethought that went into it, and lots of development of the components and, like I say, the suppliers to provide those components for us.
Let me accent one more time. If the project involves new concepts, new systems, new designs, watch out. Be sure you don't cut costs by knocking out these confirmation tests. If it's a new design, this was a very new design. And luckily, not luckily, but with good forethought, they had done a good job and it paid off big time.
Let me just ask a question here, though, Bruce. And again, I wasn't there, so I wasn't involved in this, but it might be important for future. Even though you're right, costs were not cut in many cases, I do remember a lot of concern about the size of the containment, that we had to reduce the thing down because that was costing a lot of money, and yet I heard a lot of things, you know, for the grapevine, that might have been false economy because there just wasn't enough room for laydowns and so forth and so on. And I wonder if you or someone here who really was involved with that could articulate whether that was a wise move or not.
Oh, I think you'll always need to have extra space when you're in the field. I can recall when we had to replace the primary pump because of vibration that developed. Completely, a piece of equipment, the pump, had been fully tested in the vendor's shop, but it still had to be replaced. We needed that space in order to handle that unexpected event.
Lower containment also was a very difficult place to work, maintenance-wise. Having worked within engineering throughout the operation of the plant, we ran into situations where equipment either had to be repaired, maintained, or replaced, and working in the lower reaches of containment was extremely difficult. There were many times when we had people down there crawling around on their hands and knees or lying on their backs trying to get some piece of equipment out of there. Very unique and special rigging had to happen in order to move equipment around. You may have heard of the Burma Road, which was built, so to speak, or maybe pieces of structure were removed such that we could actually get a piece of equipment and an electromagnetic pump back out of the plant after we replaced it. So it became difficult.
You're absolutely right. Below the main floor, it was extremely crowded, very confined. Chuck used to get me to go with him on a weekly walkthrough of the plant, that we got to know the plant better. And we often went below the floor into that area. We crawled around, saw equipment that was soon to be covered up and never seen again. And it was the maintenance people can attest to what you say.
Yes. One of the good things we did do, though, is we had a captive maintenance group as opposed to a job shop type maintenance facility. We had our own pipe fitters, we had our own electricians, we had our own instrument techs, and that really helped us maintain the plant because those people did all that work. They became very senior, they became very knowledgeable, and therefore you had that expertise to draw on when you had to go in and do something again maybe that you did 20 years ago. So that was a very good thing to do, was to have a captive maintenance facility or group.
What they're referring to, before we go on to the next topic, is early on in the FFTF project, I think it might have been 1970, 71, the decision was made to reduce the cost of the reactor plant by reducing the size of the reactor plant and saving basically dollars on reinforcing bar and concrete, because part of a reactor plant's cost depends upon its size. And it was recognized at the time, both within Westinghouse and in the client shop, that if you reduce the size, you're going to possibly create later maintenance problems. And what Bruce and Chuck were referring to, going down and seeing the reactor plant at the lower levels, so it was not only understood by the engineers and the maintenance people who were working there, but also by the senior management and by the client, so they could understand the difficulty of any job that must take place later in limited confined space. So recognizing that in advance, actions were taken to mitigate or preclude complications later. Our next topic we'd like to talk to is the project organization and management. And there was something unique on this project that doesn't exist on other projects, at least not in my experience with projects. And let's let, and the client was organized differently and we were organized differently, and let's let the senior representative from the client shop speak.
Well, project organization and management. The project featured decentralization of the government project direction and control through a project office, local project office, and with contractor project management through the Hanford Engineering Development Laboratory. As we recall that the project was established by AEC REGT headquarters as part of the FBAR program. And they initiated the early stages of the project with project control resting with the headquarters organization. This had the advantage of tying it in with the larger FBR program, but the disadvantage was that the project began to struggle in the early stages because of lack of specific direction and control. So AEC stepped in when it became obvious that the project was going to founder, and established the FFTF project office locally, a small 60-man project office with local both contract and technical control of the project. It was then the Hanford Engineering Development Laboratory was established under that as the contractor project manager for the project. The project was re-estimated, and there's a firm cost and schedule established for the first time for the project with that project office.
Let me add that that schedule, those dollar costs remain fixed for the remainder of the project's life. I was amazed that we did hold the scheduled dates and the cost all the way to the end. Beyond moving on, the project was controlled and people were focused intensely by the major objectives of the project: sodium fill, initial criticality, full power, end of testing. And those goals were kept in focus for all people in the field, in the plant. I mentioned earlier that the project benefited strongly from having the field office for our customer be technically able. And they again and again and again participated with us in technical issues, decisions, and it helped us enormously to have not administrators across the table, but technical people with the project slant. I want to emphasize one further point. Early during the project's life, the decision was made that the startup testing would be performed by Hanford, not by the construction contractor. The construction contractor would do the testing that's required by code, for example, leak testing of piping, and stop there. They would not run this enormous number of startup tests. So we benefited by having that decision that there will be a program test engineering organization that we will contract with them to do the work in the plant and not look to Bechtel as the construction contractor,